This is LeetCode reverse bits, and although this problem says it's easy, I think the optimal solution is not easy to think of. And we'll start with the easy solution and then go into the more difficult optimal solution after. So the most obvious and easy solution is to start with our integer, convert that to a binary string, reverse this by just looping through it backwards and putting everything into a new string, and then converting that back into an integer. The problem with this solution is that we have to do a very long process. So convert it to a string first, reverse the string, then convert it back to an integer, and it's just not optimal. So what's the optimal solution? So the way to think about this is that this digit here, actually this digit, and this one is this digit, and so on. So what we want to do is actually go through one by one and use bitwise operators to grab the right digit and put it into a number. So really the way to think about it is saying we're going to add 1000 plus 0000 plus 0010 plus 0000. And this will give us our final answer of 10. And of course, this represents 8. This is 0. This represents 2. This represents 0. Now the question is, how do we do this in an algorithm that works for any number? What we want to do is take our number 5 and shift it over 3. Right, because it's going to shift over 3. And so now this will be 0, 1, 0, 1, 0, 0, 0. So we just shifted it over 3. Now we want to AND this with 0, 0, 0, 1, 0, 0, 0. And so this will give us 1, 0, 0, 0. And so what is this AND that we're doing here? Well, this is just an 8. So we shift it over 3 and we AND it by 8. And that will give us our first digit here. And then we add that to our result and move on. Okay, now we want to move this 0 over. So again, we're going to start with our 5. We're going to shift it over 1 this time. So we're just moving 1. Now we'll end it by 4 for 1, 0, 0. And you can kind of see the pattern. So we're going to do this again, this time for this 1. So it'll be 5. And this time, instead of shifting left, we're actually going to shift right by 1. Now we'll end by 2. And then we do it one more time. In this case, we shift by 3 because we want to move this 0 over 3. And we end it with 1. And so if you actually do this calculation, you'll see that it equals 10. And by the way, I'm using 4 bits just because it's easier to demonstrate. The same algorithm works with 32 bits. So now how do we make this into an algorithm? We just need to do a loop. You'll notice that we just did this operation 1, 2, 3, 4 times, which is the number of bits. And we just need to figure out what we need to do for each iteration, what this number is, and what this number is. So we'll call this number here our shift amount. And this is going to equal our bits minus 1 minus 2 times I. And then we have to represent this, and that is our AND. And what are we going to AND by? Well, it's simply 2 to the number of bits minus 1. So 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. Now we know what we need to do for each iteration. We can simply just have a result variable, loop through bits number of times, and add to our result using this shift and AND. So this is an O of 1 time complexity algorithm because we just go through a loop 32 times, which reduces down to 1. And it's an O of 1 space complexity algorithm because we're just storing a variable for the result. And the result is an integer. Now, before we get to the code, which will make things a lot clearer, if you found this helpful so far, please give a like and a subscribe because it really helps the YouTube algorithm. And let's get to the code. Okay, first thing, let's create a variable to store the number of bits that we have. And our result is 0. Now we'll loop through for I in range bits. And now we set our shift amount. So we said it's equal to bits minus 1 minus 2 times I. And our AND amount is equal to 2 times bits minus 1 minus I. And then we just add to our result n shifted over by shift amount and then ANDed by AND amount. And then we return result. Now there's one problem with this, and that's eventually shift amount becomes negative. In our 4-bit case, shift amount becomes 3, then 1, then negative 1, then negative 3. And we can't shift left by a negative number. So we'll need an if condition here. If shift amount is greater than or equal to 0, we do our current logic. Else, we do very similar logic, except we shift to the right, and we ensure that shift amount is positive. and multiplying a negative number by -1 will make it positive. And that's it. So I don't think this is quite an easy problem, but you have to keep in mind bitwise operators are a much faster way of dealing with binary operations. So if you found this helpful, guys, please give a like and a subscribe because it really helps the YouTube algorithm. And I'll see you next time.